zeros of polynomials. These are our solutions to our polynomial functions. When we set the function equal to 0 and solve for x, what do we get? Now, our degree will tell us exactly how many zeros we should have. However, some of these zeros might be complex, and therefore they would not cross the x-axis. Remember, only real zeros touch the x-axis. Okay, I want to remind you about factor form and zero form. A factor and a zero are related. If x minus a is a factor, then the corresponding zero is x equals a. We can also call this a root or a solution. Now, sometimes factors repeat or happen more than one time, and therefore we could say that that zero repeats. If a factor repeats, it will affect the behavior of the graph around the zero. We call this multiplicity. The multiplicity of a zero is the number of times the zero or factor is repeated, and it will affect our behavior of our graph. If you have a factor x minus 3 squared, this factor is repeated twice. Therefore, x equals 3 is a zero with a multiplicity of 2. So the exponent will give you the multiplicity if it is in factored form. Now, depending on whether the multiplicity is odd or even is how our behavior looks on our graph. If you have odd multiplicity, your graph will cross the x-axis at that zero. If you have even multiplicity, your graph will not cross, but instead will come down and just barely touch the graph and turn back up. I call it kissing the axis. It kisses the axis. Let me draw you a picture. Okay, so odd multiplicity. Here's a x-axis. We're just going to draw a really big x-axis and talk about different multiplicities. If you have odd multiplicity, your graph crosses. So a multiplicity of 1 will look very much like a line because it has linear behavior. So this would be a multiplicity of 1. A multiplicity of 3 is also odd, but it will look more like a cubic around the x-axis. A multiplicity of 2 looks very much like a parabola right there at the x-axis. Notice it just comes down, touches, and pops back up. So this is a multiplicity of 2. Now, the higher the multiplicity, the flatter the graph gets around the x-axis. So a multiplicity of 4 looks very much like a multiplicity of 2, but it is very flat. And this would be a multiplicity of 4. So if you know the multiplicity, you can sketch the behavior of the graph around each zero. If you are looking at a graph, you should be able to make an educated guess on the multiplicity or how often that zero occurs.